Let's talk about Pluto, a celestial body that has captured our imaginations for nearly a century. It's a world shrouded in ice, a distant point of light that has challenged our understanding of the solar system. For most of the 20th century, everyone agreed there were 9 planets, a comforting and easily digestible fact that was taught in classrooms around the globe. This model of our solar system, with its neat arrangement of planets, became ingrained in our collective consciousness. With Pluto proudly holding its place as the 9th, the smallest and the most remote member of this planetary family, it seemed like a permanent fixture in the cosmic landscape. Pluto was the tiny, icy outlier, our solar system's distant frontier, a mysterious realm far beyond the familiar gas giants and rocky inner planets. Its remoteness only added to its allure. We learned its name in school, built models, and accepted it as a planet without question. Pluto was a fundamental part of our understanding of the universe, a stepping stone in our journey to comprehend the cosmos. Discovered in 1930 by Clyde Tombaugh, a young astronomer diligently searching the night sky, Pluto represented a triumph of human curiosity and perseverance. Pluto symbolized our urge to explore, to push the boundaries of knowledge, and to venture into the unknown depths of space. It was a beacon of discovery. But science is always evolving, constantly refining its understanding of the universe through observation, experimentation, and critical analysis. As telescopes improved, becoming more powerful and sophisticated, our ability to observe the distant reaches of the solar system increased dramatically. We found Pluto wasn't alone. Other icy worlds lurked in the same region, populating what we now know as the Kuiper Belt. This discovery challenged Pluto's uniqueness. One, Eris was even more massive than Pluto, further complicating the picture and raising questions about what truly defines a planet. Suddenly, our tidy 9-planet system was in question, thrown into disarray by these new discoveries, and the realization that the outer solar system was far more complex than we had previously imagined. The International Astronomical Union had to decide, what exactly is a planet? This became a central debate within the scientific community. In 2006, after much deliberation, they set new rules, and Pluto didn't make the cut, failing to meet the criteria for a full-fledged planet. Pluto was reclassified as a dwarf planet, a new category created to accommodate objects like Pluto that share some, but not all, of the characteristics of a planet. The public was upset, feeling a sense of loss and betrayal as a familiar friend was seemingly cast out from the planetary family. Childhood mnemonics no longer worked, leaving many feeling disoriented and nostalgic for the simpler, 9-planet solar system they had grown up with. But this wasn't a demotion, it was science refining our understanding, a testament to the dynamic and ever-evolving nature of scientific knowledge. Pluto didn't change. Our knowledge did, expanding to encompass a more nuanced and accurate picture of the solar system. Its story reminds us that science is about questioning and discovery, about embracing new evidence and revising our understanding of the world around us, even when it challenges our deeply held beliefs. So, what is a dwarf planet? The IAU's checklist. First, it must orbit the Sun, not another planet. Second, it must be massive enough for gravity to make it round. This is called hydrostatic equilibrium, gravity shaping a world into a sphere. Most asteroids are too small and stay lumpy, but dwarf planets are round. Third, and crucially, a dwarf planet hasn't cleared its orbital neighborhood. That's the dividing line. Dwarf planets orbit the Sun and are round, but they share their space with other objects. They're not failed planets. They're just in crowded neighborhoods. This isn't about worth, it's about classification. Dwarf planets are independent worlds but not gravitational masters. They're a unique class, revealing the complexity of our solar system. And Pluto leads the way. Here's the heart of the debate, the crux of the planetary definition, clearing the neighborhood. This single criterion separates the planets from the dwarf planets, and it all boils down to gravitational dominance. It's not just about being big, it's about being the boss of your orbital space. A planet dominates its orbit, exerting its gravitational will over everything in its path. It's the undisputed ruler of its celestial realm. This dominance is achieved by sweeping away or capturing other debris. Over eons, a true planet either absorbs smaller objects into itself, or slingshots them out of the solar system entirely. It's a cosmic game of cleanup. Earth, our home, and Jupiter, the solar system's behemoth, are gravitational heavyweights. They've cleared their orbital paths with authority. Look at their orbits. Nothing else of size shares their paths. They stand alone, the undisputed champions of their respective zones. Jupiter's gravity even shapes the asteroid belt, preventing it from coalescing into a planet. It's a testament to its immense gravitational power. But what about dwarf planets like Pluto? They live in crowded regions like the Kuiper Belt, a swirling disk of icy bodies beyond Neptune. Pluto shares its orbit with many icy bodies. It's not the sole gravitational ruler of its space. Instead, it's just one resident among many, a member of a bustling community of icy objects. It hasn't cleared its neighborhood, and that's the defining difference. That's the key difference, the dividing line between planet and dwarf planet. It's not just about size, although size does play a role, but about gravitational influence and the ability to dominate one's orbital space. Planets are masters of their domain. They've earned their title through gravitational prowess. Dwarf planets are members of a population, sharing their space with other celestial bodies. The discovery of Eris, more massive than Pluto, presented a challenge to the existing definition. It forced astronomers to draw a line, to create a more precise and scientifically sound definition of what constitutes a planet. If Pluto was a planet, so was Eris, and potentially dozens more icy bodies lurking in the outer solar system. The clearing the neighborhood rule keeps the list meaningful, preventing it from becoming an unwieldy catalog of every icy rock in the Kuiper Belt. It's a logical physical distinction, based on the fundamental laws of gravity and orbital mechanics. Pluto's story is about how we define worlds, how our understanding of the cosmos evolves, not just about how many planets we can count. And that definition, like our understanding of the universe, keeps evolving as we continue to explore and discover. 2006 was a turning point for astronomy. The discovery of Eris forced astronomers to reconsider what makes a planet. At the IAU meeting in Prague, scientists debated fiercely. Some wanted to call any round object orbiting the Sun a planet, making the list much longer. Others argued for a stricter definition based on gravitational dominance. In the end, the clearing the neighborhood rule won. Pluto, Eris, and Ceres became the first dwarf planets. The decision was controversial, some scientists still disagree, but it gave us a clearer, more practical way to classify worlds. The debate continues, but for now, the definition stands, and our understanding of the solar system is richer for it. Pluto isn't the lonely wanderer we once thought it was. For a long time it stood as the solitary sentinel at the edge of our known solar system. But as our telescopes have grown more powerful, and our understanding has deepened, we've discovered that Pluto is actually part of a much larger family. There's a whole family of dwarf planets lurking out there in the cold, dark expanse beyond Neptune. These aren't just asteroids or icy rocks. They're celestial bodies with enough gravity to pull themselves into a roundish shape, just like the major planets. Meet Eris, the troublemaker. Eris is a fascinating object that played a key role in the reclassification of Pluto. Its discovery forced astronomers to really consider what it means to be a planet. Eris is more massive than Pluto, and for a time it was even considered a potential 10th planet. And like any good celestial body, Eris has a moon called Haumea, which is named after the Greek goddess of lawlessness. Eris orbits far beyond Pluto, way out in the scattered disk, a region even more remote than the Kuiper Belt. It's a realm of icy objects flung into highly eccentric and inclined orbits. Eris is covered in frozen methane, giving its surface a bright reflective sheen. This frozen methane hints at the dwarf planet's frigid temperatures and distant location. Haumea is a fast-spinning, football-shaped oddity. Its strange shape is a direct result of its rapid rotation. And it has two tiny moons, Haumea and Namaka, which are thought to be fragments from Haumea itself. What's even more intriguing is that Haumea possibly has a ring system, making it only the third object in our solar system known to possess rings. Makemake is a classic Kuiper Belt object, residing in the same general region as Pluto. Makemake is smaller than Pluto, but still large enough to be considered a dwarf planet. It also has a thin atmosphere that freezes and thaws as it orbits the Sun. This atmosphere is similar to Pluto's but much thinner. And then there's Ceres, a world that stands apart from the others. Ceres is the only dwarf planet located in the asteroid belt. Nestled between Mars and Jupiter, Ceres is round, and it contains a third of the entire mass of the asteroid belt, making it a truly dominant object in its region. What makes Ceres particularly fascinating are its mysterious bright spots, which have captivated scientists for years. These spots are possibly salt deposits left behind by a subsurface ocean, hinting at a potentially habitable environment beneath the icy surface. Each dwarf planet is unique, a testament to the diverse processes that have shaped our solar system. Each one has its own story and mysteries, waiting to be unraveled by future exploration. They're not just small planets relegated to the fringes of our solar system, they're distinct worlds, each with its own unique characteristics and history. Studying them reveals the incredible diversity of our solar system and provides valuable insights into the formation and evolution of planetary bodies. These worlds bridge the gap between the rocky planets of the inner solar system and the icy giants of the outer solar system, offering a glimpse into the wide range of planetary compositions and environments. They're time capsules from the solar system's youth, preserving clues about the conditions that existed billions of years ago. And they're just the beginning, a hint of the countless other dwarf planets and icy bodies that likely populate the outer reaches of our solar system. The more we look, the more we find, and the more we realize just how much there is still left to discover beyond Pluto. Where do these worlds hide? Most live in the Kuiper Belt, a vast, icy region beyond Neptune. It's a cosmic attic, filled with relics from the solar system's formation. Pluto, Haumea, and Makemake all call the Kuiper Belt home. Beyond that is the scattered disk, where Eris wanders on a wild, tilted orbit. These regions are hard to explore, but they hold countless secrets. Closer to home, Ceres lives in the asteroid belt between Mars and Jupiter. The asteroid belt is mostly rock and metal shaped by Jupiter's gravity. Ceres is the only object there big enough to be round. Dwarf planets cluster in these special regions, remnants of a chaotic past. Their locations tell the story of our solar system's birth. The 5 official dwarf planets are just the start. Astronomers believe there are many more, dozens, maybe hundreds, waiting to be found. The search is painstaking, scanning the sky for faint, slow-moving dots. Powerful telescopes and computers help spot these distant worlds. New discoveries like Gong-Gong, Quaoar, and Sedna are strong candidates. The Vera-C-Rubin Observatory will soon scan the entire sky, revealing thousands of new objects. Each discovery adds to our understanding of the solar system's formation. The age of dwarf planet discovery is just beginning. Every new world is a clue to our cosmic origins. The hunt pushes technology and imagination to the limit. We're mapping the solar system's true extent, one world at a time. The frontier is wide open. Why care about dwarf planets? They're not just curiosities. They're keys to our origins. Dwarf planets are time capsules, preserving the building blocks of planets and life. Unlike the big planets, they haven't been reshaped by intense geology. Studying them is like planetary archaeology. They may have delivered water and organic molecules to early Earth, ingredients for life. The New Horizons mission showed Pluto as complex mountains, glaciers, a blue haze, maybe even a subsurface ocean. Dwarf planets can be dynamic, not just frozen relics. They expand our idea of what a world can be. Each one is a laboratory for understanding the solar system's past. They may even hold clues to life's beginnings. Exploring them is exploring our own story, and there's so much more to discover. The story of dwarf planets is the story of science. Always questioning, always evolving. Pluto's reclassification wasn't an end, but a new beginning. We now see the solar system as a complex ecosystem, not just 8 planets. Dwarf planets fill the outer regions, holding the secrets of our solar system's birth. They remind us the universe is more crowded and interesting than we imagined. Some may even have subsurface oceans and organic materials, potential habitats for life. The search for life now extends to these distant, icy worlds. Next time you look at the night sky, remember, there are hundreds, maybe thousands of hidden worlds out there. They're the silent majority, holding the keys to our past and future. Pluto is no longer just the 9th planet. It's the ambassador to a new realm. We've only just begun to explore. The universe is waiting, and the adventure continues.